Thank you everyone for attending today's session with SMA about the repowering solar project with the SMA CORE1. We're going to cover specifically mostly the 33 kilowatt unit that SMA has, but we'll also touch at the 50 and the 62 kilowatt and how they work. So thank you. Thank you, Mike, for arranging this. I think it'll be very good for people to learn about this product. If you can go to the next slide. Before we get started, I want to talk a little bit about Frankensolar and where we've come from and what we do. We're a solar equipment distributor. We started back in 1990 in the Franken region in Germany, which is in Bavaria. And actually, one of the first inverter partners we've had was SMA. We've worked with SMA since the very beginning, back in 1990. So it's been a long relationship, and it's been very good. In 2011, we moved into the North American market, where we established a headquarters in, at the time it was Mississauga, Ontario. We've since moved into a bigger warehouse in Brampton. And then we've also opened the second location 2 years ago in Edmonton as well. We've probably supplied more solar projects in Canada with equipment than anyone else. We've done over 10,000 systems that we've supplied equipment to. We've worked with some of the biggest aggregators, and that's why the number is so high. Guys like Grasshopper, for example, we've worked with those guys in the past. So, and then a bunch of other big names. And we have 15 full-time staff at the moment, and that's been very steady over the last little while. The next slide, please. So what makes us different from some of our competitors out there, some of the other distributors in the solar market? Well, we've been around for a very long time. As I mentioned, we've got lots of really experienced guys on our team. It's more about quality as opposed to quantity here. And I think you'll notice the guys, the people that have worked with us, they will know that we generally pay a lot of attention to detail and really making sure that the right products are being selected for the project. Because we've been around for a very long time as well, we've got great relationships in place with manufacturers out there, obviously with SMA for a very long time, but same on the panel side and racking side and Banzo system, everything. And our education piece is very important as well. Like I said, we try to really help design the proper systems, and we're not just order fulfillers. We really try to work with you, and if we notice something that could be done better, we usually point it out as well and try to save some money that way, because a lot of money can be saved in the short and long term by selecting the right products and designing the systems properly. Of course, we're very competitive on the pricing side of things, trying to keep our overhead as low as possible so we can be very competitive. And something we just started is the free shipping portion. So any order that you place with Frankensolar that is over $5,000, we do free shipping for. Next slide. And I want to talk quickly about why this webinar and why the CORE1. So we've seen, specifically in Ontario, we've seen a lot of repowering of older solar projects. Projects that were built in 2012, 2013, and onwards, where inverters are failing, companies are no longer in business or aren't honoring warranties for a variety of reasons. And the SMA CORE1 33 kilowatt unit is the most flexible product out there. It has 6 MPPTs, 12 inputs, a very wide voltage, DC voltage window, and we can also derate them. which is very important for some feed-in tariff projects that are out there. It allows you to stay within the parameters of your contract. Also, because it can be derated, you may not have to, you can just do a quick swap with your old inverter that you're replacing, and you may even get around doing some certification or ESA certification, depending on the application, which then you don't have to do rapid shutdown, meet rapid shutdown requirements, etc. And even if you do, it has an integrated stand, so it's very easy to place within what the rules are here in Ontario and Canada, within 1 meter of the solar array, and avoid rapid shutdown that way. And the last reason is SMA products just work. If you've used SMA in the past, you'll know that the products are rock solid. My dad actually has a SMA system on his farm, and on 2 trackers, and they were installed in 2012, and we haven't had to do anything on those 2 inverters. So rock solid product. And that's the last of me. So I'm going to pass it on to Mike, and Mike, I can take it from here.
Awesome. Well, thank you, Danny. And on the call, I don't know if Rob wants to chime in, but Art and Rob from SMA are also on this call, and so all of us are available as resources for anything related to SMA that you have questions on. Danny mentioned, and also someone who's already asked in the chat window about potentially derating the inverters, so I'll briefly talk about that, but Rob from our apps engineering team is definitely a resource if you need to go through the process of actually limiting the output power for the inverters to specifically meet or match a replacement device. So that definitely is possible. And there was also the mention of rapid shutdown. I'll talk briefly about that. But the CORE1 line definitely has a lot of flexibility in terms of meeting rapid shutdown requirements for the U.S., and so I'm not sure exactly the differences in the language of code for rapid shutdown in Canada and what you might have to comply with, so I'll briefly mention what the CORE1's capabilities are. And we'll go through this, and I am going to focus on the 33 kilowatt model of the CORE1. I'll show a little bit of information about the 50 and the 62, but for repowering, there are some specifics for the 33 that make it very, very useful. And Danny's putting into the chat that hopefully everybody can see that Frankensolar can actually derate the CORE1s in-house as a service. So there's extra ability to do that without even needing to bother with talking to SMA. So my name is Mike Mahan. I am one of the technical trainers for the Solar Academy, and reaching out to me at training@sma-america.com is perfect for any questions we don't get to. During this presentation, please throw out any questions you have in the chat window. Like I said, if we don't get to them, you can either follow up with me, or if it is something more appropriate for, say, Rob or for Art, I am more than happy to pass those on as well. So feel free to use that email at any time to send questions on. I want to give a brief intro on SMA's repowering division. There's actually a whole group within SMA now for repowering over in Europe primarily, but even now in North America, there are plants that are getting to the 10 to the 15-year age point where there still may be good revenue opportunity for the plant, but because of either the manufacturer is no longer in business for the inverter, or obtaining spare parts is becoming problematic, where if something breaks, there's a big uptime hit because it takes a long time to source spare parts, or just the inverters are significantly below what state-of-the-art is now for efficiency. So there may be all sorts of desires for repowering. And that is really why SMA has created a whole division for this repowering effort, to recognize that possible revenue from these plants through the remaining lifetime of any sort of contract they have. So SMA's repowering division can lean on all sorts of other groups within SMA in terms of technical implementation, and some of that is more specific to larger plants where the larger central inverters are. So definitely if you have different plants, maybe the CORE1 is the right item, but there is a bigger portfolio that the repowering division can draw from as well. And the repowering team, it is funny, they've handled sites that aren't very old, but more are close to 10 years old, and that's where you're definitely getting into the scenario where the array, the modules were only rated for 600 volts. All of the cabling, the wiring, all of that was set to be run at 600 volts or below, and most new commercial inverters, and that really includes the CORE1s, are rated for working with 1,000-volt DC arrays. And this is why the 33 kilowatt version of the CORE1 is most attractive in a lot of scenarios for repowering. And the 50 and the 62.5 kilowatt models for the CORE1 really you can leverage them and get the most benefit if the array is really working at voltage levels that would be appropriate for a 1,000-volt array. So the 33 shines when being considered to be paired with an array that is limited to only going up to 600 volts. So it can work very well without having to modify the existing array as more of a swap-in for existing hardware. And if you look at what quote-unquote commercial inverters would have been 10 plus years ago for SMA, around 2007, our 125 kilowatt Sunny Central that was over 3,000 pounds was 94% efficient, coming out at 480 volt three-phase. And we'll start looking at the DC tracking ranges for these devices fairly wide for the 125, 230 to 550. A few years later, we had the 250 or 500 kilowatt inverters that were significantly heavy. The efficiency was improving in a decent voltage range, but again, up to 600 volts only. So devices like this were used for what at the time were quite large PV plants. And then before we had our tri-power line of commercial inverters, the centrals were getting larger, so we wanted to have a device that could work as a three-phase inverter for moderate sizes. So we had our Sunny Tower, where we would have 6 single-phase Sunny Boys gang together so that they would be 2 groups of devices attached in three-phase. So this was our commercial line before we had our tri-power line. So with the tower and these heavy transformer-based inverters, we're still looking at 1,400 pounds and not quite the 97% efficiency that we saw before with, decently wide operating windows. So systems using the older SMA inverters, those arrays would be expected to be in the 350 up to about 500 volt DC range to work with the inverters we had. But now we have a much nicer, easier to use, I think, inverter family. So the CORE1, when we modified it to the -41 part number that you see here, we had started the family as a 50 kilowatt unit. Now there is also the 33 and the 62 models. They physically all look the same, so if you were considering speccing one in, they're really all of the same footprint, weight, all the functionality, and very, very flexible. As they are commercial inverters, they are listed up to 1,000 volt DC. Obviously can work to up to 600 if you want to limit it there. And the architecture of this device has a lot of benefit both for new commercial construction, but also for retrofit. On the input side for the DC, the inverter has its inputs broken up as 6 independent maximum power point tracking channels. And the inverter can handle each of those 6 inputs independently, and they don't all need to be connected. So if you have a smaller existing system, I saw in the chat somebody asking about a 16 kilowatt system, definitely if you wanted to only attach a few of the MPPTs, definitely you can plug up some of them and leave them unused. But the inverter handles each of those 6 tracking channels independently. and there are 2 string connections, 2 positives and 2 negatives for each of those tracking channels, but each can be driven fully through a single positive and negative input. So you have those 6 tracking channels with lots of flexibility for different string lengths or different orientations. Generally, all of the products that we had showed before, our central inverters, 125 and the 250 and the 500, all had a single tracking channel. So you may not need all of that flexibility, but as part of a retrofit effort, if the array is being investigated and there are modules that are underperforming, damaged, whatever, the flexibility to perhaps remove a few modules and end up with different string lengths if you are putting the CORE1 where that combiner box might have been, where you expected many equal length strings to come in, you now have the flexibility of having potentially different string lengths come to the different input channels for the CORE1. So as the inverter hardware is being modified, the array can be investigated, and if modules need to be quote-unquote orphaned, you may leave them in place for visual appearance, but just disconnect them electrically. The CORE1 can handle that very easily. Each of those input tracking channels, the voltage range that they work in, the inverter needs to see 188 volts DC to start making power from them, but then is programmed to be able to work down to 150. So the 150 to the 1,000 volts DC is the operating range for this device. So very wide range. And we'll talk about the CEC efficiency, the California Energy Commission efficiency, and how that is calculated. That is where the 33 kilowatt unit shines in respect to retrofit into the lower voltage arrays. The inverter on the AC output side is a 277 480 grounded wide device, so there is not a 600 volt 3-phase output model for this, so that is the AC output for the CORE1. The U.S. models have both the DC disconnect that you can see, and on the opposite side have an AC disconnect built into them. So you have that balance of system componentry there in the body of this device. And like I said, we'll talk a little bit about the SunSpec integrated rapid shutdown and talk a little bit about shade fix. But before we get there, I want to point out a little bit on the spec sheet that allows or will highlight the benefits for using this in a retrofit scenario. So again, we have the 33 kilowatt, the 50 kilowatt, and the 62.5 kilowatt units. All of them are rated up to 1,000 volts DC. Each input channel, and actually per string, since you can drive each input tracking channel fully through a single string input, the limit for short circuit current for those inputs is 30 amps. In operation, the inverter will pull a maximum 20 amps from those individual trackers. So 20 by 6 is 120 amps total. But for SMA, what we care about in terms of hardware limits, 30 amps short circuit in the best conditions, highest irradiance, and 1,000 volts DC. So coldest temperature, none of those inputs are exposed to more than 1,000 volts. Again, as a retrofit, obviously that's less of a concern, but with those two limits, we have up to a 1.5 DC to AC ratio. That means that for the AC limit of the inverter, you can go 150% above that to get the maximum STC rating for an array that we would allow to be attached to these units. So for the 33 kilowatt unit, up to 50,000 watts STC rating array would be allowed to be attached to that. Again, you have to maintain respect for the voltage and current limits, but within that you can go up to 1.5 ratio. I mentioned that the inverter can work between 150 and 1,000 volts. The rated MPP range, and this is the top section of the CORE1 data sheet here, so that third line down, the rated MPP voltage range. What that is the voltage range at which the CEC efficiency is calculated. So the 97.5% CEC efficiency for this device is calculated within that 330 up to 800 volt range. So if you were looking at a retrofit situation, as I showed the SMA older hardware, generally the 300 to 500 range would have had to have been achieved for those devices. So that 300 to 500 range is almost completely contained in this range where that 97.5% efficiency is achieved. And again, it can work below that 330, but 330 and above, you will have that 97.5% efficiency. So very, very high efficiency device to be used in the retrofit, even if you're staying at 600 volts and below. I think that is all I want to mention on this slide. I had a question about some physical specs, a little less than 2 feet by a little more than 2 feet by about 29 inches. We do include 4 commercial rooftop feet with each and every CORE1. Those may be of use if you are mounting it in some other way. Each CORE1 unit ships on its side on a small pallet, so you have access to the bottom of the body and the threaded screw holes there where those commercial rooftop feet would attach. So if you're not using them, if it's a different racking structure, perhaps you're mounting this where a combiner box for a central had been, or some other style of mounting, you have access to the bottom of the body immediately. At about 185 pounds for this unit. You see the operating temperature of -25°C to 60°C. The storage temperature for this device is -40°C up to +70°C. So it's fine to have this exposed to temperatures between -40 and -25. If the inverter turns on and it's -30°C, the inverter will wait until its internal temperature sensor hits -25°C to start making power. So it's safe to be exposed to down to -40, but it'll start making power at -25. A little more information, gory technical detail. There is an efficiency and derating document for our devices. So this is just for the CORE1 33 kilowatt unit, but all units will have data like this. You'll see how the CEC efficiency is calculated is several points in terms of loading with respect to full output power. So perhaps 10%, 30%, 50%, 75%, 100%, and those will be weighted at certain values. And furthermore, you're taking that weight over 3 DC input voltages to get that calculated value. So the minimum side for that calculation for the 33 kilowatt was the 330 volt. And so at 330 volts, you can see those different weighting levels and what that efficiency would be. So at light loading, the efficiency you can see for all those voltages drops off seriously, but once you're past 10 or 15%, you're going to be at least above the 96%. So lower voltage, you would expect it to be slightly below, but you should still be getting quite high efficiency, generally flat in terms of relationship to the loading of the device. But again, above 330, climbing towards the 600 volts, you should be in that 96 to 97% range for the device. And with respect to temperature, again, the lower voltage generally is less efficient, so there's a better chance for derating, but even at that 330 volts, the ambient temperature needs to be over 50°C before we saw any impact. So again, you could scale that if you went down in voltage. This might creep down a little bit in temperature, but you should still have a very, very robust temperature range to not be concerned at all about derating. I want to look a little bit about physical wiring of the device, how you might be considering using this for a retrofit situation, and look at the electrical limits of the inverter. We mentioned the 1,000 volts DC, 30 amps short circuit, but again, remember the 20 amps is what the inverter will draw in operation from each of those tracking channels, and it can do that with both positive and negatives or a single positive and negative, so it can pull that full 20 amps using a single positive and negative input for each channel. So looking at older modules that might have a slightly lower short circuit current than we would be expecting for current modules coming off of shelf today, modules up to close to 8 amps ISC can work well using 3 strings per input of the CORE1. So again, you have the 2 positive and negative inputs on the device itself, but since you can drive each channel through a single positive and negative, you can use a combiner, either a actual cable combiner with fuses or some other type out away from the inverter, and then bring back a single positive and negative to each tracking channel. I'm going to mention this again and again and again. Our repowering team has asked me to mention this ad nauseum. The one thing you cannot do with the CORE1 is combine or gang together the 6 tracking channels. So if you're using all 6 input tracking channels, at a minimum, you will have 6 positives and 6 negatives coming back to the inverter. So you cannot combine those 6 tracking channels in any way. You can bring more than 2 strings, perhaps if the current values work, to each tracking channel, but you cannot gang those 6 tracking channels together. So physically, if you look at the wiring area, you'll see A through F. Those are the 6 tracking channels broken out on the inverter. You have 2 positives, 2 negatives per. Again, if you're using a single positive and negative to drive that channel, you would cap, and we're providing you in the accessories bag with each and every CORE1 these connectors that are available, bulkhead connectors on the CORE1 are Amphenol UTX connectors. We are providing you in the accessories bag the ferrules and the mating connectors, the Amphenol UTX mating connectors, to connect to those bulkhead connectors. So we're giving you the hardware for the other end of your home run cables. So if these were cables coming into a combiner box, we're giving you the hardware, if you're replacing the combiner box with the CORE1, to attach those cables to the inverter directly, and any unused inputs are simply plugs. So we're giving you the plug caps, we're giving you the Amphenol UTX connectors and the ferrules for use with those home runs, and there's an equipment ground bus bar for the DC side right there as well. So if you had those ground conductors coming back to the combiner box, all of that would be accessing the same space physically there on the CORE1. In U.S. code, in the 2020 code cycle, there definitely was a very specific call out now for all connectors on the DC side of a PV array. Connectors must be the identical type from the same manufacturer, or they must be tested and listed for intermatability. So we are giving you the exact connectors from the same manufacturer to connect to the body of the CORE1. So I'm not sure the status in Canadian code of a similar requirement, but if it is there or appears shortly, we're definitely giving you those identical connectors to have the connections be fully code compliant at the body of the inverter. So again, if you're using a single positive and negative, if you have 2 or potentially 3 strings, if those are being combined away from the inverter, the negatives and the positives being combined and then brought back to a single positive and negative, then simply cap the other positive and negative, and you can drive that tracking channel fully through a single positive and negative. Again, the one thing you cannot do is gang any of those 6 together, but you can drive each channel fully with combined strings, as long as you were respecting that 30 amps ISC, and again, remembering that the inverter will pull a max 20 amps in operation. So as a kind of thought exercise, let's look at a older system, assuming a 250 kilowatt roof system, Denver, Colorado, so cold. Maybe you experience colder temperatures where you are than Denver gets to, but we got down to 0 Fahrenheit a couple times here in this past winter, so it does get a little chilly here. So we'll look at these older Sharp modules. If you look at the spec sheet, we have a short circuit current there of 7.82. So all of this looks reasonable to possibly bring 3 strings together to an input of the CORE1. And that IMP, we might have a little bit over 20 amps. So again, the inverter might hold at 20 amps, and that might be a clipping potential. For the hardware limits, we look like we're going to be good. And let's check this now in Sunny Design. So we see we have a 600 volt rated module. What are we going to have here? So I'll pull up Sunny Design, but this is the design screen from Sunny Design. I've already picked the location, picked the tie-in, and we have these Sharp modules. Sunny Design does have a very robust database of legacy modules. I don't think we ever take anything out of the database, so you should be able to find fairly old modules. If this is a retrofit situation, the array type should be there in the database. So we've pulled up those modules and put them together. You can change the roof mounting style if it's a flat roof rather than this type. That's fine. We've changed the orientation and the tilt. And then we will try to string this 250 kilowatt array into the 6 CORE1s. And you can see here we have the array. If you want or have sections that are facing different orientations, you can have 1, 2, or 3 subarrays per project in Sunny Design. So if there was an east-facing part of the array and a west-facing part of the array, that can be easily handled in Sunny Design. And we have as inputs here strings of 14 modules, and some inputs have 2 strings, some have 3. So we do get a warning from Sunny Design. It will tell you that you are exceeding the number of actual connectors on the inverter. So it gives you that helpful hint that some of these inputs cannot physically accept directly 3 strings, and it will also give you a suggestion that perhaps you are going to a higher DC to AC ratio than is quote-unquote standard. So we're going to a 1.26 DC to AC ratio. Again, that is fine. We are staying under the 30 amps short circuit limit you can see in the lower right here. And we're definitely staying under the 1,000 volt input limits. So those hardware limits have been satisfied. So we're safe going up to this 1.26 ratio. And you can see this energy usability factor, 98.6%. This energy usability factor is a metric from Sunny Design that gives you an idea of how much impact the program believes your PV array scenario with this inverter with a high DC to AC ratio will actually result in clipping. If that energy usability factor is 100%, the program does not believe that there is any scenario for the location and the mounting style you have chosen with this PV module for the inverters that would ever lead to clipping. So the program is saying that it does expect some impact for clipping, and you can see that it is expecting a couple of these inputs, the ones with the 3 strings combined, to have a current that might be above the hardware limit. So the inverter will hold at 20 amps. So if there was a scenario where the modules could provide 21 amps, the inverter is simply going to limit them to 20. So that's why this is slightly under 100%. So Sunny Design will actually give you some suggestion of when, if it thinks clipping is going to come into play. But we can very nicely bring many of these strings together for each CORE1. These CORE1s are all wired the same, so if we had a combiner box, we have, what, 3, 6, 9, 15 strings here of 14 length coming to each CORE1. So depending on how the hardware was set up that we're expecting to replace, it might be that the combiner boxes have a certain number of strings coming in, and we want that certain number of strings to land on each CORE1. You have some flexibility to adjust these, potentially use different size CORE1s or different stringing combinations. So this tool will give you a lot of flexibility to try different combinations, check loading ratios, and check the clipping impacts, potential clipping impacts. A question coming in on the chat, does CORE1 require the DC inputs to be balanced? So the answer is no. Generally, good practice is to kind of balance the hardware. And coming into the inverter, there is detection on inputs A, B, and C, and D, E, and F, so that I think in a perfect world, if you could balance across the 2 groups of 3, yes, but the inverter will work fine with unequal loading. And so we had commented that for the situation we have, we might want 3 strings, and again, it was 14, not these 12, for the design we just showed, to come into the certain input channels. Again, there you have 2 positives and 2 negatives. We can drive each channel fully through a single positive and negative. So here we're showing what we call like an X-branch connector, where we have inline fuses for the 3 inputs, and then the output will bring those 3 combined positives, and here the 3 combined negatives back to the input of the CORE1. So there may be some hardware adjustment that you're doing. If all of these strings were coming back just to a combiner box, you may be putting something, inline fuses or a cable like this in some way to bring this down to a single positive and negative to each input channel for the inverter. But there's quite a bit of flexibility to make the wiring and the connections work well. So a lot of the retrofit benefits, we're talking about the higher efficiency. Again, you're coming in with a new inverter with a 10-year warranty that can be extended out to 20 years. AFCI is built in that may not be in the device that you're replacing. We have the surge protective device accessory kit for both the AC and the DC side. in the inverters, you can set up production watchdogs to have the input channels benchmark against each other, and through our data manager registering the system on NXOS, there is quite a bit of flexibility to dig down into the input levels of the inverters and see what is going on. In terms of service too, the CORE1, we have actually a board swap program for service support of this device. So once it's in place, if something were to go wrong, there is the option to do a board swapping for this device. And I just want to show some folks the physical layout for the CORE1. So as I mentioned, each device ships on its side on its own pallet, so you have access when you unbox the device. There is the accessories bag on a cardboard tray on the top of the inverter, so you take that off. That has a bag with all of the mating connectors, so you have the ferrules and the hardware to connect all strings to the inputs of the CORE1, as well as plug caps for any unused inputs. The 4 rooftop feet are stacked here in the recess at the bottom of the inverter. You have the mounting hardware for that, but if you're not using those feet, you have access to the threaded screw holes on the bottom of the body immediately for attachment of whatever would be the appropriate hardware. And the 4 moving handles, one thing, these are not rated for long-term UV exposure. They will eventually degrade, so you do get a set with each inverter. Go ahead and place the inverter and then take them off. Keep the set, on site. Give everybody who's working with these devices a set to keep in a truck, but go ahead and take them off of the body of the inverter once they are used to place the device. The SPD kits, I had mentioned those. There are the SPD kits for both the AC side and the DC side for either type 2 or type 1+2 for the inverter. The holders for these SPD bricks are built into each and every unit. The accessory kit is just the SPD bricks that plug into the holders. So for the AC side, it's just a small cardboard box with the 4 SPD bricks. The DC side kit is actually 9, 6 positive, 2 negative, and a ground. So there's 9 in the DC side and 4 in the AC side, but that's all it is just the SPD bricks. The universal mounting system is an SMA mounting bracket for the CORE1 for really just wall mount, so that may be of use depending on how you're using this and where you're placing this. If you're popping it in placement of an existing wall-mounted string inverter, definitely could be useful. The sensor module is a card that plugs into the communications board of the CORE1 and allows for 2 temperature sensors, and a radiance meter and a wind speed meter to be brought directly into that data to be brought directly into the communications channel of the inverter without the need for a standalone weather station. So that could be useful depending on where the inverter is placed. And again, the data manager would recommend this device for really even small systems. If you're popping in 2 or 3 CORE1s, would definitely think you should consider the data manager for not just monitoring the systems, but control as well. So I have a couple pictures of the SPD kits here. Again, the DC side here, you'll have the 9 bricks. The holders, the hardware, the DIN rail with the holders here for both the DC side and the AC side, again, are installed in each CORE1 at the factory. So when you get the accessories kit, you're just getting these bricks and you populate them during installation. So that's all the accessory kit is. A little bit of a picture from the installation manual for that universal mounting system. Again, it is the bracket that attaches to the wall is really the full width of the inverter, so it would not be appropriate for like a carport stanchion, but could be useful. And the sensor module, again, the sensor module is just the card that plugs into the communications board of the CORE1. So this black piece behind the board is the CORE1 communications board. You have your 2 Ethernet jacks built in, so you can daisy chain the inverters for wired connection for monitoring potentially through the data manager. But the sensor board is just the plug-in board that attaches to the communications board. And SMA does not sell the sensors that would attach to it, but we do have an approved list of sensors that we know work with the device. And we're showing here the data manager, again, kind of a command and control device for multiple inverters, and can also use data from an energy meter with CTs at the point of interconnection to control the output of these devices. While that is primarily used for newer installs where there's some type of export limitation, the data manager can handle and bring in the data from multiple of these energy meters. Where that ties in relation to our discussion of repowering is if you are putting in CORE1s for a device that has failed, but there may still be some legacy non-SMA inverters that are not being replaced at the same time. If you have the meter, the LCORE meter, with the CTs on the output of those non-SMA inverters, the data manager interface will show you very detailed information for the CORE1s and can also bring in the energy meter data that is at least showing the output of those non-SMA inverters and have all of the PV system information on one portal. Again, those non-SMA devices would be less, there would be less data there, but at least you would have the output data from those other devices along with the information from the SMA inverters, and you would have a single portal visibility for that whole PV system, even if it's a mix of SMA and non-SMA systems. This is a kind of a poor, I apologize, kind of a poor demonstration of that, but hopefully you can see in very small print here we have a power from an SMA plant, and then it says power grid feed in LCORE meter 1, power grid feed in LCORE meter 2. So we have two meters here and the SMA output all showing on the same plot. So that would be the style that we would be talking about. You could see the non-SMA hardware monitored through the LCORE meters, and then the SMA information would be coming directly via communications into the data manager, visible locally or on the new NXOS portal. And again, showing a little bit about the monitoring for through the meter for control for export limitation. It is very direct to use the data manager with the LCORE meter and appropriately placed CTs to do that export limitation. Okay, I want to kind of segue a bit and talk a little bit about power production for the CORE1. This is kind of a slightly off topic, but definitely we've been talking quite a bit about shade fix. So I want to make sure folks are aware of this for functionality built into the CORE1 for retrofit or existing plants. We talk about for the U.S. For compliance with rapid shutdown, there are some very stringent requirements for rapid shutdown that even if the CORE1 can be placed very close to the array, now we are generally required in certain states, most states, to have module level separation when rapid shutdown is triggered. So we have a per module device, the TS4RF, that can work with the new CORE1s very directly to achieve that compliance. And there is a transmitter in the inverter that simply broadcasts a keep alive signal to those module devices. So if code here requires us to have that module level isolation, we want the devices that are doing that isolation to be simple code compliance devices, as low part count and high reliability as possible, leave only the function that has to be in them, and leave all of the heavy lifting for the system in the inverter. Far easier to access, generally a easier environmental condition than behind each and every module. So behind that belief, we have our shade fix optimization in both our residential and commercial string inverters. And what shade fix really does is it prevents a statement that you may have heard out in the industry from being true. And that statement is that a string inverter is limited to operating a string of modules at the point of the weakest or least productive module in that string. So it is simply an optimization, an add-on feature to a standard maximum power point tracking algorithm that in conditions of partial shade, the lower two rows here, can allow the inverter to decide if it makes sense, and that means do we get more power by having the partially shaded parts of the module contribute voltage, but thereby limiting current in the rest of the string, or isolating the partially shaded parts of the string and allowing the unshaded parts to work at higher current. And so the shade fix, there's a sweep function that allows the inverter simply to determine which of these points produces more power. And so it does that very, very efficiently and is not always in operation, but is always checking periodically to make sure the system, even in conditions of partial shade, and this could be snow impacts, whatever, is working each string, or really for the CORE1, it's each input channel at the best possible power point. So it's managing all 6 of those inputs independently. They could have different impacts on them, and the inverter is juggling all of them simultaneously to ensure they're doing the best output. And we like the shade fix scenario for the fact that it's not putting complex electronics on each and every module and suffering reliability and efficiency hit like you would have with standard module level power electronics. The analogy here would be those devices are like always on 4-wheel drive. They're always in operation whether or not they're needed. An overall efficiency hit here, we're showing miles per gallon, but it would be kilowatt hours coming off of the system. You take an efficiency hit for having that always on device at each and every module, whereas the shade fix is based in the inverter, is periodically checking to make sure the system is working optimally and therefore results in a higher overall system efficiency. And you can get some information about a shade fix in general, including a year-long study from the University of Southern Denmark that showed by comparing 3 identical systems that the SMA shade fix system actually produced more AC kilowatt hours over a year-long study period with lots of different shade scenarios than a standard DC optimizer architecture. So we think the inverters do very well. So you'll have the high efficiency device with the shade fix optimization for mitigating partial shade with or without any module level power electronics. So to close, I want to kind of plant a seed for the repowering department, give you an idea of actual project they've worked on that use the CORE1s. Like I said, they have the full arsenal of SMA equipment to use, but this was a specific project that worked very nicely for CORE1s. So it was not a very old system. I believe this was done last year, and so the year of commissioning means that the system was only 5 years old when they came in to do this repowering. So it was 200 kilowatt inverters that were from quote-unquote competitor X that were being replaced. So it was just a low inverter availability concern, and then there was no warranty extension on that hardware available, so the decision was made to go ahead and take out the hardware and replace it. The PV array was sun power modules, but this is an important point that I hadn't mentioned up until now. The CORE1 is a transformer-less inverter, so the only time that it cannot be used is if there is a requirement, physical requirement from the PV array that either the positive or negative DC conductor be grounded. That's not all that common, but SunPower was a manufacturer that was fairly popular in the 5 to 10 year, maybe 10 to 15 year range, and they did have a product line that did physically require grounding of the array. In this scenario, though, the positive grounding was not required, so this product of theirs did not require that. So that was a first hurdle to check when considering repowering. So that opens up the possibility for using the CORE1. This scenario already had a 480 volt tie-in, so the AC output from the inverter, there did not need to be much modification except for potentially breaker sizing, but there didn't need to be a concern about a transformer tying into the service at the building. Again, that's another consideration that may or may not be required for a certain site. But the setup they had, it worked out fairly well. They had inverters that were down on the ground, but looking at the project, the CORE1s actually went up and replaced combiner boxes on the roof. And so the inverters that were down more at the ground level would actually be replaced by an AC combiner box. So the AC outputs of the inverters that will now be on the roof would come down off of the roof, and there would be several of those. So there would be an AC combiner box to have all of those breakers tied together, have a master disconnect for the system here by the tie-in where the older inverters had been. So then the DC home runs that had gone from the combiner boxes off of the roof to the inverters, that section was modified and replaced by the AC output of the inverters down to that AC collection panel. So the consideration, like we showed in Sunny Design, there was a setup where they have these lower current modules, so they were using inline fuses to combine multiple strings to inputs of the CORE1. But other than that, no changes in the PV array were required. So a pretty easy setup for this scenario. And then it is the repowering department would go in and check lots of different combinations, strings per combiner box. They have an initial setup for some of the different inverters, and then they can figure out which models of the CORE1. You can see that both the 33 and the 50 were considered based on the architecture of the system and to give different DC to AC ratios. So definitely the repowering group is ready to crunch numbers like this for fairly large systems. If you have smaller systems, it might be far more manageable. This is something you could easily do with the help of just Sunny Design, but SMA is ready to assist for the slightly larger scenarios that you might run into as well. And so to close up the discussion here, and I want to open the question, the chat window for questions. Again, just some things to keep in mind. You know, do any of the DC wires need to be restrung? Are the inverters going to be placed where the combiner boxes may be, or are they going to go where the existing inverters would be? Things like that. If we need to change a section of conductor run, is it going from DC to AC? How many strings can each CORE1 MPPT input safely handle? And again, a big red flag check before it does the array that you are working with require grounding. Again, you have the transformer-less inverter, so neither the positive or the negative conductor from the array can be grounded coming into the inverter. And again, the repowering department made me say this many times. Please note, when using the CORE1, the one thing you cannot do is gang those 6 MPPTs together and try to bring a single positive and negative back to the inverter and then split it out into 6 positive and negatives. The inverter will not operate, so you do have to connect each of these 6 tracking channels independently. And to close up, let me go ahead and ask for questions, funnel anything into the chat window, but I want to give a shout out to SMA's service app. So if you go to either the Apple or the Android stores, you can find the SMA service app. If you download it, please, on either the menu or if you have a globe icon on the top right on the home screen of this app, you should be able to set language and region. And if you set that to English, US, you'll see the US models for the inverter. So you'll see the prior generation and the current generation of the CORE1. That will be there. Documentation, the failure analysis screen is simply to be able to enter an error code and help troubleshoot the inverter. The preventive maintenance for the CORE1 is dead simple. This is the fan tray, so there's a handle there that you turn. You can drop the fan tray. There are 3 fans in it. We would ask just to make sure that that airflow path in the inverter is maintained clear, and that will be obviously location dependent, but that is really it for the preventive maintenance. If you have the AC or the DC side SPDs installed, a visual check of those likely would also be on the preventive maintenance cycle. But other than that, it's very straightforward. Again, there were no series fuses inside the inverter. If you are setting it up now where there are inline fuses somewhere outside of the inverter, that obviously would probably be part of the check, visual inspection or any sort of electrical checking. Again, logging into the inverter via the data manager allows you to look down to the channel level of each inverter, so you would be able to see how those inputs are operating. So that would be a very easy way to do a check. If you have 3 strings being combined, if one of those fuses was blown, you could easily see have lower current coming in on that whole input. It'd be very easy to eyeball that as well. finally, the CORE1, we do have a board swap program for the CORE1. You have to go through a short certification training program to be eligible to receive boards for the inverter, but it is possible now to do board swaps to repair the device potentially versus a whole device swap out. And there are 6 boards in the inverter to do that service on, but it's pretty straightforward. One thing is, if you have gone through this program and have done the training, you, a couple years down the road, get a board swap to do on the CORE1 in the service app. If you click on the repair tab, the CORE1 is there with instructions for that board swap, so you'd have those instructions at your fingertips, even if you didn't remember the training program. So it's very, very useful in all aspects. Okay, and with that, yeah, let me open up the window. I think, Danny or Art, if you want to comment on anything that we've talked about, I will start going through the chat window and catching up on questions here.
I just also want to mention, thank you very much, Mike, it was very informative. But I also want to mention that Frankensolar does have an in-house electrical engineer with named Alexander Wolf. Many of the participants here already know him, but we would definitely be very happy to assist anyone that has questions about stringing and finding the right solution for re projects to help, you know, pick the right solution and help with any questions that may arise. That is something that we do offer, and there's no charge for that.
Excellent. There are a couple questions coming in the chat window talking about this being able to be outdoors. Most definitely. Again, I mentioned the storage temperature down to -40°C. The ratings here, the 3SX rating is the testing for the AC and the DC handles to ensure they are operable if laden with ice or snow. And again, you're correct, definitely the airflow path is up the center of the device. This begins as a natural convection, just free airflow, and the fans that are in the fan tray, it is located here at the bottom center of that thermal chimney. They are speed controlled. So as the inverter temperature goes up, at some point the temperature sensor will turn the fans on, and then they're speed controlled based on the temperature of the inverter. If, say, a bird built a huge nest on the top of this device, that just means that the cooling of the device will be less efficient. If the fans are on, they may not be able to push air over the heatsink fins that are in this thermal chimney. The inverter will eventually get to the point where it will derate. The only thing it can do to generate less internal heat is to process less power. So at some point you will just see the production linearly drop off. So if the fans are on at full blast and the temperature is still going up, you'll get to that derating point. And that's what this curve in the lower right of the graph here is showing. Again, this is assuming an unimpeded airflow, and the fans can work. But given that, even if it's very hot air that is flowing over those heatsink fins, really up to 122 degrees Fahrenheit, you're not seeing a concern for derating. Again, as you go down in voltage, the efficiency of the device is going down. So you would expect, if you're trying to run this at that minimum voltage, that would creep in some, but I think you should still be fine probably up to 45°C. And again, if that airflow path is impacted, then you're just reducing the ability of all of the built-in systems to cool the unit. So that's what we're saying, is that these derating starts would creep in lower and lower temperature if this airflow path is impeded. So is it wall mountable? Yes, we showed the universal mounting system for the device. That is definitely one way to do the wall mount. I'll go ahead and pop to that screen. So this is an actual SMA wall mount system. Several folks they use this to great effect in carport systems. So then the stanchion, you can see the one diagram with the X here. The stanchion is likely narrower than the width of the inverter, so I wouldn't necessarily call that wall mount, but pole mount is possible. That would not be appropriate for this mounting system, but definitely folks have built their own support structure that actually connects directly to the carport stanchion and very securely supports the inverter. Again, they're tying into the threaded screw holes here on the two bottom arms of the inverter, and they generally leave a very nice airflow path up the center core of the inverters. So yes, definitely possible. Great questions. Outdoor mountable on flat rooftops, yes, definitely connecting, however, to potentially extensions of the PV array, or if it's a very high wind zone, there might be need to be a roof penetration anchor that somehow secures the device. But yeah, there's been a lot of different installation methods on flat, very low slope roofs. Not a problem at all. Okay, well, great questions. Anything else before we let everybody get back to their day? Okay, I don't see anything else in the chat window, but yeah, as Danny said, feel free. I think very comfortable in handling most questions for SMA directly, and if there's a need to send it on to any SMA folks, definitely can do that. Tim, a question about 480 version. Is there a 600-volt version coming soon? I unfortunately have not heard of any rumblings that there would be a version that would natively output at 600 volts three-phase, so I don't want to instill any hope that it is coming. I would be pleasantly surprised if so, but I have not heard of any such device.
SMA's Peak 3 is 600 volts AC. However,
yes, the 150 kilowatt version is, yep.
Yeah, so it's 150 kilowatt Peak 3, and it does not have ESCI, so it's not suitable for rooftops. That being said, for any ground mount, certainly that is a solution that is out there. That's a 1500 volt DC concept as well, which is quite nice.
Yeah. Yeah, that one is, yeah, it's a very nice machine, but definitely, as you said, more for, I think, the larger scale ground mount.
Correct, yes, yeah. So, the 600 volt AC always comes up in Canada because a lot of
of course.
Yeah.
Awesome.
Yeah. Well, thank you very much, Mike.
No, definitely appreciate the opportunity.
And yeah, thank you everyone for attending.
Thank you.
Awesome. Yeah. And as I said, Danny, I'll work with Art and we'll get you the recording as soon as possible. Shouldn't be too long, so probably sometime tomorrow we'll get you the presentation and the recording for distribution.
Awesome. Yeah, if anyone would like it that is attending this, send us an email and we'll be happy to share that with you.
Awesome. Well, thank you, everybody. Definitely appreciate the opportunity to speak with you. Stay safe and enjoy. Hopefully the weather's pretty good. Enjoy the weekend. Take care.
Sounds good. Thank you, Mike. Bye.